Friends, today we will talk about software testing, also called verification and validation. We call it VNV as well. Why we need testing? Because software programs faces a lot of problems, issues, bugs. Could be defects in the field or during testing and like that. So there could be calculation error, security error, okay, unit level error, system level integration issues, feature function related error, syntax error, logical bugs, and sometimes system becomes very slow also, it creates the performance issue. That's why software testing is required. So software testing in general is like you have your requirement phase, design, coding and implementation, and then you have testing. So multiple type of testings are being done, and then after testing release will be made, release software will be released. Now what is the objective of software testing? Objective is prevent bugs, ensure that we find the bugs and error, reduce the risk, evaluation of the work product, verify the requirement, functions and feature, validate, test and object, and build confidence in the product or service which we are offering. So through testing we build the confidence with the customer, we give them assurance that yes, the product or service which we are going to offer to you is defect free, it will work smooth, it will perform well, right? So this is what the objective of software testing or in general testing is. Now principal objectives of software testing could be basic focus is on the basic usability, basic accessibility, mainline product functions and all these things, error condition and all these things has to be found in as a part of principal objective of these are the principal objectives of software testing. Now verification and validation are the two activities which are part of the testing. So verification says or it asks the question, am I building the product right? I repeat, am I building the product right? In validation we say, am I building the right product? So there is difference in these two. Validation says, am I building the right product? Okay. So in this your acceptance, usability and all these things will come. In case of verification, unit integration, all automation, and then there is a combination of regression testing, beta testing, system testing, all will also come. So VNV, verification validation, I hope you are clear about the difference. We will see one more table of verification validation. Verification says, as per IEEE, the process of evaluating the software to determine whether the products of a given development phase satisfy the condition imposed at the beginning of that phase. Again, the definition of validation is the process as per IEEE 610, the process of evaluating the software during or at the end of the development process to determine whether it satisfied the specified requirements or not. Okay, so whether we have built the right product or not, we have satisfied the requirement or not, comes under validation. Again, verification is a process to ensure whether we are developing the product accordingly or not. Validation is the process to validate the product which we have developed is right or not. Verification is verifying the document, code and all these things. Validation is to validate the actual and expected output of the software. Activities involved here are the inspection, review, walkthrough, testing and all that. Activities involved here is validation, testing of the software application, it is the low level activity. Verification, validation is a high level activity. Okay. Verification is a static method of checking documents and files, and validation is a dynamic process of testing the real product. Verification, as we have seen, am I building the product right? Verification says, am I building the right product? So here we have seen right product, here also we have seen the right product. Now testability, again this diagram is there where we check about your observability, okay, smallness, isolability, deployability, efficiency, reuse, all those things are being checked. Cost of quality. Cost of quality is our cost of good quality, cost of poor quality. Cost of good quality is your prevention and the appraisal cost. Cost of poor quality is internal failure and external failure. So in this way, cost of quality, we call it COQ also. COQ is being called as COQ also, which is your cost of quality. Cost of quality, again it is in pictorial tabular form, which says cost of good quality, cost of poor quality, prevention cost, appraisal cost, internal failure cost, external failure cost. So two categories and subcategories are there. Now, though I did not talk about the detail, but every type of cost of quality we have some subcategories and types also. So if required we can talk about it. So let me show you again this particular chart. It says that your FMEA, FTA, process capability, okay, all these things will come under prevention. Appraisal cost is your incoming inspection, your calibration, your auditing, everything will come under appraisal cost. Your internal failure is there is process delay, there is rework, there is scrap, okay, retesting, validation, loss of capacity, and all these things are there as a part of internal failure. External failure, where it goes to field and it results into a failure during usage or during field trial. Okay, now each and everything we need to do the calculation in terms of efforts, and we calculate the cost of quality. Now coming to that, how is the relationship between the quality and the cost? So as you can see this, the total cost of quality, COQ, again cost of quality. So here we have the prevention, inspection, internal failure and external failure. Four types we have seen. So these are the so this is your prevention cost, which will go up. Your failure cost, here it is very high, but as you go ahead it will become less. So like this, the total cost of quality, COQ, here it is optimal level. So it has optimized here. If we follow all the processes, and number of defects will also come down. Now difference between quality assurance and quality control. Quality assurance is you give assurance through the process and you ensure that compliance are there. Quality control is something which is right, you conduct review, you conduct testing, okay, you do the inspection and all these things. So both are have different meaning or different purpose and objective. In QC, we have in QA we have your audits, root cause analysis, documentation, process improvement. QA is process oriented, it is more proactive. Okay, it improve processes and procedures. In QC we have testing, we have inspection, we have automated testing, we look for the bugs, errors and all these things, we do the product sampling. So you can look at this, what is the difference between QA and QC. Another differentiation between QC and QA and QA and QC is QA is your focus is on the process, proactive, okay, it prevent defects, it focused on the audit. Quality control, which is QC, focused on the product, it is reactive, it is purpose is to find defects and it involves lot of testing called verification and validation. Now let's have a look at the SDLC, software or system development life cycle. Okay, start with the planning, analysis, design, development, testing and deployment, and maintenance. So in planning you prepare the project plan, you make the schedule, you have the risk plan, you configuration management plan, quality assurance plan. In an analysis you have the requirement. In design you have high level design, architectural design, detail level design, lower level design. In development you have coding and prototyping and all these things. In testing you have unit integration, system testing and deployment. Once all is being done, then you get into the maintenance phase of the product or service. Again, this is the various stages of your software development life cycle. So planning stage, analysis stage, design stage, development stage, testing stage, integration stage and maintenance stage. So multiple stages are there. Now first stage, which is your requirement analysis, is you get knowledge about the requirement, you identify the stakeholders, you collect the requirement, you analyze the collected requirements, then you prepare the system requirement specification and you manage all this requirement through requirement management process. In the design, architectural design is there, high level design is there, detail level design is there. So here we have seen the multiple stages of requirement phase. Here there are different types of different stages of design, different levels of design. At high level design, in high level design we HLD we have requirement, design decision we take, we make the business case, we have the conceptual architecture, we prepare the view with respect to requirements, we have business, data, application, technology views, implementation view and layered view. So this is the part of your high level design. Then next is your detail level design, we also call it as your sometime lower level design also. So from SRS you go for design analysis, you go for architectural design, you have detailed design, you prepare design documentation. In the detailed design process you analyze the system or software requirement specification, you generate the or improve the detailed design architecture, you evaluate detailed design alternative, select the final design, and then once the design is finalized you prepare the detailed design document called DLD, detailed level design. We call it lower level design also. And sometime we follow the top down approach. So we start from the top module, we go for sub module 1, sub module 1.1 or like that, and from the top, from the software, we go for the module, sub module, or like that. This is called your top down approach of the design and development. We have the bottom up approach also, where we go from the below module to the higher module to higher module, and finally result into a final product and system. So this is the diagrammatic view of your top level design, top down integration testing, and top bottom up integration testing. So here the testing will start from the top. Here in the bottom up, you start from the smallest module and move up in the this hierarchy. There is one more concept, that while writing the code, the team has to follow the coding standards. Coding, whatever language you are using C, you are using C++, you are using Java, Python, .NET, C Sharp, and all these things. So coding standard has to be followed. So there you check for the inline comment, uses of global variable, you ensure that structured programming is being done. Then you follow the naming convention, you ensure that error and exception handling is being done. You check the coupling, cohesion of the software which you have written. So these are the software engineering terms called coupling and cohesion, which is being used in the coding phase. When the coding phase starts, coding is undertaken once the design phase is complete. During coding phase, every module identified in the design document is coded and unit tested. Unit testing is the testing of different module of a system in isolation. Now the type of testing which we have unit testing, integration testing, system testing, and user acceptance testing. Once all these things are being done, we go for the implementation, where the installation of product in an operational environment is being done. Once all these things are being done, then we get into the maintenance phase. In the maintenance phase, as per the IEEE 91, the process of modifying the software or system or component after delivery to correct the faults, improve the performance or other attributes, or adapt to a change in the environment. System maintenance is concerned with the modifying the code software once it is delivered to the customer. So here also we maintain the maintenance log, we prepare the design change document also. Type of maintenance could be your corrective maintenance, adaptive maintenance, performance maintenance, and all this preventive maintenance are there. So in corrective maintenance, we correct and fix the bug. In adaptive maintenance, we migrate to some other platform, other ID, other tool. Okay. Perfective maintenance is we do some enhancement to improve the performance, and preventive maintenance is like we are trying to prevent any future issue or future bug or any breakdown of the system or product. System or software lifecycle models are we have waterfall, rapid application development model, spiral model, V model, incremental model, agile model, iterative model, and big bang model. These are the various type of SDLC models we have. Then the project management, which is being used to manage this complete activity of design, coding, testing, verification, validation. We have planning, we have execution, we have monitoring and control. These are the multiple phases of. So with this, let me end this session over here. I'll come back with few more concepts which are related to your testing, your design, because video is becoming very bigger, and I will start with the repetition of this plus how the project planning, management, risk management, everything is being done, and then again we will come to the software testing, how the testing will be done. Thank you very much.